All right, I'm pleased to introduce Jack Tuszyn from the University of Alberta, Canada, Edmonton, Canada. And your field is very cutting edge intersection of physics and consciousness that, well, why don't you go ahead and
Yes,
explain
indeed.
what you're doing.
I'm a cell biophysicist, and I'm interested in inner workings of a living cell, in particular nerve cell neurons. And I'm interested in physical models, predictive models, that will help us understand how parts of the cell are integrated into a coherent structure. And other people are working on how neurons are integrated into the brain, but I want to understand the lowest level, the lowest physical level of organization, structural, spatial, and temporal organization. That is how this machinery works all together. And I use physical models, I use biochemistry, and cell biology.
So when we say, is it discovering or creating those materials? I mean, that particular group, the idea that the quantum effect can occur at room temperature, and you're saying that the quantum physicists say, no, it can't. We know that, but there's another camp saying, this is a fairly new field, it's only some 70 years old, and we can't possibly know everything about it yet. So
exactly. Yes, I would like to remind the viewers that there was exactly the same controversy with superconductivity. In fact, there were papers published, I believe in the 70s, that demonstrated decisively, conclusively that you couldn't have superconductors at above 18 degrees Kelvin. And
blown that threshold.
And exactly 10, 15 years later, experimentalists in Zurich found superconductivity at 30 Kelvin, 35 Kelvin, then 90 Kelvin. Now it's in 110 or 120 Kelvin. So the temperature is rising, and these are, as I say, macroscopic quantum effects. And so it's 15 years. Now look at nature and the billions of years of experimentation with various types of material.
Gotcha.
Right.
So you think you're onto something?